Okay, so I'm going to brief you on part A, your assignment. Okay, first few questions on what you need to do. Okay, so the first one is you have to set up your, let's say I assume that you have already installed your Linux OS. Now the next thing you need is these two components. Okay, so for part A of the assignment, you're going to study, okay, your how to write a multi-threaded process, a simple multi-threaded process, and then we're going to look at how they runs, okay, and then describe whether you have race condition and so on, and then we're going to use semaphore to solve some of the synchronization problem. Okay, now because this one will involve writing source code, okay, because we want to write a multi-threaded process, so you need a compiler. The compiler that we're going to use is GCC compiler. It's a C language compiler. Okay, now the second one we need is pthread library. Pthread library is for multi-threaded library. Okay, this is a kernel level library for POSIX Linux. Okay, the name of the library is called POSIX. Okay, now so I'm going to switch to my virtual machine. Let's say assume that you have already installed your Linux OS. So the first thing you need to do is to open up your terminal. Alright, so I open up my terminal. Okay, alright, so this is your terminal. In fact, it's a very powerful interface. Okay, your Linux, okay, main advantage is actually the main feature is actually the terminal. Everything you do is actually from your terminal. It's very powerful. Okay, now so the first thing you need to do is to switch to root, because we're going to install these two packages, these two software. We're going to install this from the internet repository. Okay, so you need to use your root user. Okay, now what is root user? Root user basically means your administrator privileged user. Alright, so now to make things simple, okay, you can switch by using SU. SU stands for switch user, and then follow by the username. So this root username is reserved. Okay, reserved for admin purpose. So on normal usage, okay, your everyday normal usage, we do not log in as root, because if you log in as root, okay, there is a chance that you're going to accidentally destroy your own OS. For security reason, you don't log in as root for normal use. We only temporarily log in as root to install certain thing. And for example, my actual user is called this one. Okay, so now in this terminal, I am logged in as, or in fact as the whole Windows here, I log in as my own user. But because I want to install some packages, okay, so I switch to root temporarily. Alright, now this password is the password that you key in when you install your Linux OS. Okay, when you install your Linux OS, it's going to ask you to set up your root password. So you have to remember that password. If you do not remember that password, there's no way to recover it, unfortunately. Alright, now I am logged in as root. Okay, this one means now I'm in this terminal. Temporarily I log in as root. Now I have the super admin privilege. Alright, so the next thing you need to do is just follow these two steps. Okay, this yum, okay, the yum here is actually the repository for Fedora. If you use Ubuntu, you're going to use you don't use yum. This yum is only for Fedora, Red Hat, CentOS. Basically Red Hat based Linux family, you use this one. Alright, so yum install. So you want to install GCC. Alright, yum install GCC. Alright, so now my machine, I already have this installed. So even I put this, okay, okay, nothing to do because I already installed this one. Alright, so the next thing you need is yum install pthread. Again, this is a threading library. Okay, oh, we don't have pthread, so it's actually called glibc. Yeah, I forgot this one, sorry. So it's glibc development. Again, you say nothing to do because I already have installed in my virtual machine earlier. Alright, so for yours, you will install, you just click, press yes, and then you will install all the necessary repository. Now, of course, your virtual machine must be connected to the internet. Okay, your laptop must be connected to the internet in order to do that. Alright, now, assume that we have already installed these two libraries. Okay, let's say we already installed these two libraries. Now, so to quit as root, now I'm still root, right? So you have to go back to your normal username. So you just type exit. So once you type exit, you go back to your own username. Alright, so now I'm in my own username. I have to download this program. Okay, so I have to download this program from my Weber. Alright, now let's say I already downloaded. Okay, so let's say I already downloaded. Okay, so you need to navigate to that. Okay, normally, okay, after you download from your Firefox browser, all your download file will be in this folder. So cd command means change directory, and then you go to download. Okay, initially you're at home. Okay, let's go back. Okay, to go back to the previous parent directory, just change directory dot. Double dots means parents directory. So initially you were here. Okay, this is the your default. Okay, your default directory for all the normal user login. So if you log in as your own name, okay, then it will be /home/ and then your own username. Okay, this is the default directory once you log into the terminal. Okay, so from here you have a lot of others. Okay, you have a lot of others files and directory. The blue color here is for directory, and this one is only true for my setting. Yours could be different if you use Ubuntu and so on. Okay, now, so like I said, most of the time the default directory for your Firefox is in here. If you download any file from Firefox, okay, Firefox, Mozilla Firefox browser, it will appear in this particular directory. So just cd change directory to downloads. Alright, so okay, so now of course here I have a lot of files here. So the one that you need is multithread.c. Alright, now for mine, let's see. Yes, because I store mine here, but it doesn't matter. Okay, let's say now I got the file. Okay, multithread.c. This multithread.c, alright. Now if you were to open it, now for mine, because I changed the directory, okay, mine is here. Okay, so your multithread.c. Now if you double click, you can see this is the source code. This is the source code for your. Okay, this is the source code for my multithread.c. So if you want to compile this program, you type gcc. This is a compiler. Compile what source code? Multithread.c. Okay, so and then the output name, let's say I call it multithread without the c. This is the output, the executable file. You can change other name, but normally we put the same name so we are not confused. And then these are the two compilation threads that you need for this program, because you're going to use pthread library, and then LRT is for the time, okay, because they are asleep later on. Okay, so you enter. Alright, now we have this program called multi-thread. So if you run this multi-thread, okay, to run from this directory, single dot means current directory. So current directory slash means you're going to run. Okay, run what program? Multi-thread without the C. Without the C is the executable file. Okay, so once I run, okay, it will say hello world. I'm thread number 0. Hello world thread number 1. Now let's look at this program. Okay, now this program, actually you start from main, right? So this program is just a simple program where we're going to create two threads called T0 and T1, okay, using pthread library. So T0 and T1 are the variable to control these two threads. Alright, now when you create this T2 T1, each of these thread, okay, what does this thread do? You have to refer to the function. So the third argument here, thread underscore T0, this is the function that going to run when you create thread 0, okay, called thread T0. So this function is here. Alright, so when I create thread T0, the function thread underscore T0 will run, and then it was printf means printf is similar to cout. Okay, it's similar to cout in your C++. So printf is C programming. So it say hello world, I'm thread number 0, and then in contrast with that, thread T1, okay, thread T1 will run hello world, I'm thread number 1, and then when they finish, you have to join these two threads together, and then that's it. Alright, so this is how we run. Now, of course, each time you run, okay, it's going to show you thread number 0 and thread number 1. We do these two individually. Okay, now you may notice sometimes why, okay, most of the time is thread 0, thread 1. Okay, why most of the time thread 0, thread 1 is because you run thread 0. Okay, this line will create, and then immediately it will run T0, but this T0 one is running concurrently. It will create T1, and then T1 also run. So there is a time that where T0 and T1 run concurrently. Alright, although you have two or parallel single core, or if let's say I have dual core setting, it means after I created T0, okay, just right after I create T0, T0 run, I create T1, T1 runs. If I have a dual core, it will run in two different processors in parallel. Now, because of this, okay, there is a chance that these two threads will run in parallel, and because there's a chance they run in parallel, there also will be a chance that thread 1 will run first. Actually, you don't know, because you don't know the scheduler will schedule which one first. Okay, but most of the time T0 will run first because you created T0. So T0 actually has slight advantage in terms of the time it started, maybe a few nanoseconds. But right after that, T1 will run. And because this is just a hello world, which is very short, that's why you will see T0 is leading most of the time when you run. But of course, there will be a chance for some reason, okay, because again, these two threads cannot control. For some reason, the scheduler may pick thread 1 first, and that's why you show thread 1 sometimes. So there is definitely a race condition here, alright, because these two threads cannot control. Okay, now study this one. Okay, you study this source code, look at how it's run. Okay, look at how it's designed. This is just a simple program just for you to play. Okay, now then we go to question C. Question C is the one that where you need to really solve, answer the question. Alright, so question 3, C is race.c. Okay, so I go back to my virtual machine. Alright, so the next one is race.c. Okay, let's say, Now if let's say you do not want to view, let's say you don't want to view from this text editor, you can actually view from this. Okay, vi race.c. vi is a text editor embedded inside your terminal. It's very powerful, but to learn this you need some time. Okay, now I'm not going to show you this one here, you take some time. Alright, let's say you use the normal thread editor. This thread editor is called gedit. Okay, gedit, gedit. Okay, now in this question, okay, let's look at the question. In this question, your process A has a global variable x, integer x equals to 2, integer y equals to 3. Now let's look at here. I have integer x equals to 2, integer y equals to 3, and these are global variable. These variables are outside the main function. Alright. Okay, let's jump back to the question. Then thread 0 will perform this, x equals to x plus y. Thread T1 will perform y equals to x multiply y. Okay, now let's look at here. So thread 0 do what? Exactly what I said just now, and thread 1 will do this. Okay, the rest are similar. Now once these two threads finish, so when they finish, we'll run these two lines similar as the example just now. Then I want to know what is the value of x and y. So after these two threads runs in parallel if you have dual core, or concurrent if you have single core, then we will have these two results printed out on the screen, x and y. Okay, so first of all, you compile this program. Okay, now you can run it like this, so it will tell you this is the result, x is 8, y is equal to 6. Now according to the question, you can run this over 100 times, 100 iteration, using this script. Now this script you download from your, okay, this script is called runner.sh. Okay, this runner.sh you have to download this from the Weber. Now when you first download this from the Weber, you cannot run this shell script. We call this shell script. Okay, now this script, or like all other executable file, okay, once you download it from internet or whatever, by default you cannot run it because for security issue. Okay, so in order to run it, you have to change the permission. So first you have to use this command called chmod 755 runner.sh. So this one will give you the permission to run this runner.sh afterwards. Okay, now what does this command do? Now this one will be in your part B. Okay, I won't explain it now. You just follow this command for now. When you go to part B, you will learn how to use chmod, and you will understand what does this command do. Alright, now so let's say you already run this one, and then your runner.sh can be executed. Now to execute /runner.sh, and then it will run this. Okay, it will run this particular race program 100 times. Okay, from 0 to 99, and then you will see the result.